Now that you understand the basics of how VMware vRealize automation works, it's time to see the solution in action. This demonstration shows some of the most innovative features of vRealize automation.
Hello and welcome to the vRealize Automation 7.0 Spotlight demo. My name is Jad Elsain and I'm a principal architect in VMware's Cloud Management Business Unit. Today I'm going to walk you through some of VRA7's innovative new features and capabilities, including the out-of-the-box integration of VIDM, VMware's federated identity management solution for the modern cloud management platform. Then we'll dive into Converged Blueprints, a unified authoring canvas that redefines the service delivery experience. And then finally, we'll wrap up with one of VRA's most exciting new features, the Event Broker, a new lifecycle extensibility platform that extends VRA into the broader ecosystem and helps incorporate external services into any application. Okay, let's jump right into this demo. First, I'm going to log into my customized login screen provided by VIDM. I also have the option of selecting an available authentication directory. In this case, it's an Active Directory domain called corp.local. Logging in takes us to our Home tab by default, where I can view and configure information portlets based on what's important to me, the logged in user. I also have the option of adding new portlets or changing the layout. But this demo is going to focus primarily on VRA7's Spotlight features, so let's jump over to the Administration tab and take a look at our first feature, VIDM. All of VIDM settings are available in the Directories Management section. Here you could add authentication sources, for example, additional Active Directory domains, and determine things like sync frequency, the target Active Directory domain, which attributes will be collected, and finally, which groups and users will be synced from the directory into VIDM. This could also be filtered for maximum control. Next, an access policy can be created to filter access into VRA by attributes such as the source network, for example, where the user is logging in from, and also the login device, iPad versus laptop versus desktop. We could also determine which user attributes are synced from the directory to the local database by specifying them in the user attributes section. Now let's take a quick look at approval policies, VRA's dynamic governance engine that provides greater visibility, more control, and the ability to incorporate external systems as needed. Approval policies are configured by the policy type, which includes all of VRA's available catalog items, or it can be based on existing items, which can point to a specific component of a broader deployment, for example, a specific software item. The approval policy is then defined using a number of settings to align with an enterprise's requirements, or provide new capabilities never before possible. Once completed and published, approval policies are applied to catalog services, individual items, or even day 2 actions using entitlements. Let's head over to the Catalog tab and take a glimpse of the services available to the logged in user. Here you can see several service categories and associated services. These services are defined by the catalog administrator and available only when entitled to the specific business group within this tenant. The catalog view shows the finished product, but let's take a step back and explore how we got here. To create any service, whether it's basic infrastructure as a service, application authoring, apps that incorporate dynamic networking, or anything as a service known as X as a service, we always start in the Design tab. VRA7 introduces a completely revamped service authoring capability called the Converged Blueprint Designer, also known as CBP. The CBP provides a unified authoring experience, allowing for the design and integration of basic or even highly complex applications, including the ability to author and incorporate applications, networking and security services, and even external services using the X as a Service Designer, which can now be dragged and dropped right onto the canvas and bound to the other components. But before we can include applications in the canvas, we must first define what those applications are. So let's explore our software components library. Here you can see a number of applications that have been previously defined or imported into the software library. The library can include web services, databases, middleware, and just about any software script or config element using basic bash command or PowerShell scripts. Let's take a look at an example software component. In this case, Microsoft SQL Server, which is actually published among several other examples in VMware Solutions Exchange as a YAML package and easily imported into this VRA instance for customization and consumption. Each software component is configured with a unique name, auto-generated ID, and a detailed description. You could also select a container dependency, such as a generic machine or more specific parent object, to dynamically build software dependencies and an execution order. Once bound to a container, the object cannot be dragged and dropped onto any other component within the blueprint. You could also configure properties that can be passed to a software component during script execution. Here you can see a set of properties that identify installation repos and other variables specific to installing SQL. Properties also enable the application architect to allow consumers to modify specific settings at request time or to dynamically consume a configuration element from another component within the canvas. Next, we configure the actions that will execute at build time during various lifecycle stages: install, config, start, and uninstall. And here we can see that a PowerShell script is used to install SQL. The script can incorporate any desired properties defined in the previous step. This makes reusing existing software installation scripts incredibly straightforward, while also adding significant capability and dynamic configuration elements that have never been possible before. A quick review, and we're ready to publish this software component and immediately make it available for consumption. Previous versions of VRA introduced an industry-first technology that allows any workflow to be quickly delivered as an entitled, governed, and lifecycle managed service. This is called Anything as a Service, better known as XaaS or X as a Service. In VRA 7, we have taken this functionality up a notch by allowing any XaaS service to also be dragged and dropped right onto the converged blueprint canvas and bound to any other component within the canvas. This enables quick integration of external systems or any of the other X as a Service use cases. So let's create a blueprint and put these technologies to good use. I'll start by clicking New to create the new blueprint. Next, I'll name the blueprint and provide a useful description. The unique ID, again, is automatically generated. I can optionally set an archive value and lease policy. The archive period determines how long to hold on to a provisioned machine once its lease expired. This could also be renewed. Next up is networking. Selecting an available transport zone in the NSX Settings tab allows us to quickly extend the power of NSX into this blueprint. This enables the use of NSX-backed dynamic networking services and app-centric security. And with a single mouse click, we can engage one of NSX's most powerful capabilities, total app isolation, also known as microsegmentation. Once you click OK, our new canvas appears, and we're ready to build out our multi-tier application. The Components library shows us all the default components and services available within the canvas. In machine types, you can see all the supported out-of-the-box endpoints, including the newly revamped vCloud Air endpoint. I can drag and drop any of these onto the canvas to start building a service based on the associated platform. But what we do now largely depends on the use case, the desired outcome, and even the admin's persona. For example, if my primary role is the IaaS admin, I might want to build the core OS or foundational services that will be offered to my organization and application architects. But in this example, my role is the application architect, and my interest isn't in the IaaS basics or even worrying about the backend minutia. It's more about the application itself. So I'll jump down to the Blueprints category and drag any of the available blueprints right onto the canvas to start building my apps. So let's build my amazing new app. This app is based on Windows and will be composed of at least 2 Windows 2012 R2 servers with an IIS web frontend and a SQL backend. So I'm going to drag and drop a Windows 2012 R2 blueprint right onto the canvas and call this SQL. And then I'll drag another one for the web tier and call it Web. Now let's add software from the software components library. For the web tier, I will need an IIS and .NET component. So we'll drag each of these software components to the web machine. And likewise, for the database tier, I'm going to drag and drop my SQL software package and also .NET to the database tier. All right, this application is coming together. Now that we've got the application basics configured, it's time to incorporate networking. So let's go to the Networking and Security library. Here you can see all the available networking options that can be used by this blueprint. For starters, any traditional existing network collected by the endpoint inventory can be dragged and dropped right onto the canvas. For NSX environments, an existing security group, for example one that was created by my networking and security team, can also quickly be consumed. Or you can opt to leverage an on-demand security group, which creates a dynamic security group using a set of predefined policies at provisioning time. For load-balanced applications, an NSX-backed on-demand load balancer can be added to the canvas as well. And this will dynamically create the VIP, the appropriate number of legs, and the load balancing policy at provisioning time. NSX also enables dynamic networking options such as the on-demand NAT network or the on-demand routed network. For this use case, I'm going to leverage the on-demand routed network to dynamically create an NSX-backed network at provisioning time. So let's drag and drop the on-demand routed network right onto the canvas. I'm going to select an available routed profile and add the name and optional description. Okay, next up is security. Since I'm going to need to protect each of these tiers, I will also be dragging and dropping the existing security groups for each one of them. One for the database tier and one for the web tier. And now that services have been dragged to the canvas, I can bind each of the components to the desired network and security groups by selecting the component and modifying the networking and security settings. As you can see, as each service was bound to the component, the canvas builds a logical connector for convenient visual of the relationships in overall network topology. And finally, the web tier of this application is going to need to be load balanced. And since the number of web servers deployed will be up to the requester, the load balancer needs to dynamically configure the appropriate policy at provisioning time. NSX provides this for us with a simple drag and drop of the on-demand load balancer. Once dragged onto the canvas, I can select which component I want to load balance, as well as the component network in the case of multi-homing. I could also select the desired VIP network. And finally, the ports and protocols that will be load balanced, which could also be edited. Now that I've got a completed application with networks and services intact, I need one final adjustment to ensure the components are built in the order of dependency. For example, I need the database tier to be provisioned and online before I can configure my web app. Otherwise, all the components will be provisioned concurrently. To do this, I will simply click on the component binding hotspot and drag it to the appropriate dependencies. And in this case, I'll drag the IIS software component to the SQL Server component. And this can be much more broad or more granular depending on the desired outcome. And there you have it, a completed application that can now be published and entitled for consumption via the catalog. And it's portable. VRA now supports exporting any blueprint in human-readable YAML format, also known as blueprint as code. Using the included Cloud Client or VRA's APIs, you could export and or import complete blueprint packages, including the software components, all the scripts, and all component properties as YAML. Next, we need to address what happens pre, in-flight, and post-provisioning and extend the automation to the broader ecosystem. And to do this, we'll tap into one of VRA's greatest new technologies, the event broker. Extending VRA and its services into the ecosystem is not a new concept. Extensibility is a critical function of cloud and machine lifecycle management, and while VRA has delivered significant extensibility for quite some time now, it has generally been perceived as overly complex and often required an extended services engagement to meet the advanced business use cases. In VRA 7, extensibility starts with creating a subscription, a policy that triggers a desired workflow based on a set of interesting events or configuration elements. A subscription can be created for each extensibility use case and can be a global policy or based on a very specific event or object. Let's walk through a very basic example. In this case, my IaaS admin would like a snapshot created for every production machine that is configured by VRA. I would normally have to create snapshots manually, but now it can be done automatically and based on a specific set of guidelines. So let's build this policy. I'm going to click New to create my new subscription. Next, I can select the event topic that coincides with my use case. As you can see, there are several out-of-the-box topics that address a vast majority of the extensibility use cases, including approvals, and the ability to incorporate external governance systems, for example ServiceNow, for approvals instead or alongside VRA's built-in capability. I could also trigger extensibility based on configuration changes of a blueprint or business group. In this example, I'm going to use the machine provisioning topic, one of the more popular topics. Next, I can determine whether I want this policy to apply to all events or for a specific set of conditions. Since I only want snapshots for prod vSphere machines and only after they've been delivered as built, I'm going to create a subscription based on a set of specific conditions, all of which should be present prior to triggering the workflow. So here I'll create a policy with the blueprint name that starts with prod, a machine type, a virtual machine, lifecycle state name, meaning when I'm going to trigger this policy during the machine's lifecycle, set it for machine activated, which means this workflow will be triggered once the machine is delivered to the requester. And then a lifecycle state phase of post. And that should do it. Let's move on to the next step. I've determined the conditions, and now I have to determine which workflow will be triggered once I have a match. The event broker makes this incredibly easy by providing Vro Workflow Inventory right here in the UI. I can browse through the library and choose any workflow I'd like to pair with the subscription. In this case, I'm going to select the vCenter workflow called Create a Snapshot. Finally, I will name the subscription and provide a useful description. And once saved, I will publish the new subscription, which immediately activates it. And as a result, all new prod machines provisioned to vSphere will be automatically snapshotted behind the scenes. This was a very basic use case, but take a moment to think of all the possibilities. Whether I'm automating snapshots or building a much more sophisticated extensibility use case, I can quickly create a policy to trigger any number of workflows during any lifecycle state using a broad or very specific conditions and have it immediately enforced at a global level, all done from a centralized UI. And back to the catalog for another look of what we're ultimately delivering to the business. A set of services completely abstracted from any one platform, any one cloud, and delivered seamlessly to the consumer, and with more automation, governance, and control than ever before possible.